The rational zeros theorem is convenient for us because it gives us a way to find possible zeros of a polynomial, which can then lead to factoring the polynomial or graphing a polynomial or other things. So what does the rational zeros theorem say? It says every rational zero. What is a rational number? A rational number is any number that can be written as a fraction of integers. So 2 is a rational number because it can be written as 2 divided by 1. 1.3 is a rational number because it can be written as 13 over 10. 1/3 is a rational number because it's already a fraction. So that means 0.3 repeating is a rational number because it is the same thing as 1/3. So, in other words, any decimal number like 2 or 1.3, any decimal number that stops, that doesn't repeat forever, is rational, and any decimal number that repeats forever is rational. Numbers that are not rational are things like pi, goes on forever and doesn't repeat, or the square root of 2 goes on forever and doesn't repeat. So these are rational zeros. Of course, complex numbers are not rational either. Okay, so every rational zero of a polynomial is of the form, it's going to be a fraction, it's of the form, the numerator is a divisor of the constant term in the polynomial, and the denominator is a divisor of the leading coefficient in the polynomial. Okay, so you get this ratio of numbers that will give you a rational number, and the list of rational numbers you get are the list of possible rational zeros for the polynomial. So list the possible rational zeros of 2x squared plus 5. So in this case the constant is 5, so that means the possible numerators will be the divisors of 5, which are 1 and 5, but also negative 1 and negative 5 are divisors of 5. So plus or minus 1, plus or minus 5 are the numerator. The possible numerators, I should say. The denominator are the divisors of the leading coefficient, which is 2 in this case. So plus or minus 1 and plus or minus 2 are the divisors of 2. Now we have to look at the different combinations. For example, I could have 1 on top with 1 on bottom, and 1 divided by 1 is 1. And then it could be plus or minus depending on your signs. I could have 1 on top with 2 on bottom, which would give me plus or minus 1/2. Finally, I could have 5 on top with the 1 on bottom, which would give me 5, or 5 on top with the 2 on bottom gives me 5/2. So there's 1, 2, 3, 4 positive possible rational zeros, and 1, 2, 3, 4 negative rational zeros for possible rational zeros. So there are 8 total, and all 8 of them are listed right here. You can test these to see if they are zeros by plugging them in for x, or by the way, none of these will be zeros in this particular case. Or you can use synthetic division to see if they're zeros by getting a remainder of 0. How do I know that none of these are actually zeros? Well, if I plug any of these numbers in for x, when I square it, I'm going to get a positive number. So anything squared is positive, times 2 is still positive, plus 5 is even more positive. So nowhere do you subtract anything here. So this quantity is going to be positive no matter what real number you put in.